Hey, today we've got lesson 5. Now, this one, for whatever reason, always seems to be the hardest rule to remember. So I really need you to focus in on this today. So combining like terms. So what that means is when we're looking at our problems, our equations, we are combining, so adding or subtracting the terms that are alike. So the ones that have a variable connected to them or the constants. So we're going to just practice combining like terms and then we'll practice solving. So here we have an example. So we're asked to simplify the expression 4w plus 3 plus 2w minus 1. So here they took that question and they grouped the terms. So you can group them, or maybe you want to circle them, square them, separate them somehow. Okay, so I like doing this as we do our equations, separating them rather than regrouping, because then you just got to make sure that you don't mess up the signs. So as I've said before, that sign in front of the number, they're attached. So that's a plus 3. This is a plus 2 or a positive 2w, and here a minus 1 or a negative 1. So when we regroup, we got to make sure that negative is still with the 1, and then the other ones are all positive. So that wasn't as difficult. So now we can combine 4w plus 2w, or here they've grouped it. 4w plus 2w is 6w, and then 3 minus 1 or 3 minus 1 is 2. So our simplified form of this expression is 6w plus 2. So let's practice some combining like terms and then we'll practice solving. So here 7x plus 10x, there's no other terms. So it's just 7 plus the 10, 17x. In example 2, we have our a's that have like terms, but then we're left with this 19 with no like term. That's okay too. So we're going to do 8a minus 5a. So again, if you want to regroup, you can, but you don't have to. If you're okay with circling, or some of you might be okay with just seeing it, but I do suggest that we do something if we circle or if we rewrite. So 8a minus 5a is 3a, and then this plus 19 just stays because we can't add it or subtract it with any other number. This example here, we've got p's and q's, so be careful. So 9p we can combine with our negative 4p. And then here we have q's, and notice I'm boxing in the sign with that number. So if you want to regroup, we can write 9p minus 4p and then negative 8q plus 4q. 9 minus 4, 5p, negative 8 plus 4 is negative 4q. So again, we've got those integers, which are positive and negative whole numbers. So if the negatives throw you off, use your calculator. So we mentioned in class, and I probably mentioned in some of the other videos about the invisible ones. So with combining like terms, writing in your invisible ones is a good idea. So as I look at this question here, I've got 11t plus 6r minus 16t plus r. So there's an invisible 1. So that's 1r. So t's with t's and r's with r's. So if we're regrouping, 11t minus 16t and then 6r or positive 6r plus 1r. So again, if you're a little unsure here, with 11t minus 16t, use your calculator. 11 minus 16 is a negative 5t. Here we've got positive 6 plus 1, 6 plus 1, so 7r. This might be a good time to pause your video, try this one on your own, and then see if you got it right. Grouping C's with C's. You know, maybe you want to underline, maybe you want to leave those other ones blank, so you don't have to do it specifically with circles and squares. You do whatever works for you. So again, you can regroup 12c plus 8c. And then I've got negative 4 minus 22. (12 plus 8). (20c). And now negatives 4c, negative 4 take away 22. You can punch that in the calculator just the way it looks. And let me point out, because I don't know if I've done this enough, but your negative sign is down here. So a negative and a subtraction sign are essentially the same thing, but on the calculator we have to make sure that we're using the correct button. So negative 4 and then minus, so I'm using the subtraction button, minus 22. Okay. Nope. Negative 26. All right, so now we've got 3 that are alike, so that's okay. You could have as many like terms as you want. I mean, you know, we can make problems with a whole bunch of like terms. And then we've got the g here, the negative 33g all by itself. A lot of times when you look for, if you're looking for an answer, we put the variable first. It doesn't matter though, because we have that associative property. It doesn't matter which way you add your numbers, we can mix this around. So negative 33, again, if we want to regroup, minus 22, minus 17, and minus 10. Okay, so we are subtracting everything here. Let's practice that again in our calculator. So negative sign is down here. So negatives first, and then I've got 22. The rest of these I could just put in subtraction. So subtract 17 and then subtract 10. Negative 49. So negative 33g minus 49. Okay. Try the 2 questions now embedded in the video. If you want to write them down here as a 7-8 at the bottom of your paper, that would be a great idea. Don't try to do the work in your head. All right, so we've got an example with solving right here, and then we're gonna do some of those together. So here in this question, they did regroup. So they took 17x and they took a positive 9x and they regrouped them, and then that negative or minus 23 they put here. So from here they combine like terms just like we did. We add those together, minus 23 stays here. So the only new part now is we have this equals 55. Well, after we combine our like terms, this looks like a 2-step. And I hope we're becoming really good at solving these two steps. So if it's helpful, you can box in your variable, and all the way down, I'll draw this line, that barrier we talk about. So now this works exactly the same. So if you can do your combining like terms and then get to your two-step, now the rest of this is just like we've done before. So this is where the inverse operation comes in. Now we've got to be careful here because we tend to get inverse operation confused with combining like terms. So up here, we're combining like terms. Let me talk about this for a minute and what the difference is. So here, this is like if we took away the equal sign, that's just simplifying expressions. That's just normal adding, subtracting numbers together. But once we put the equal sign in and we want to move this number to the other side of that equal sign or over this barrier that I've created, that's when the inverse operation comes in. Okay? So the inverse is used when crossing over the equal sign. Now I think it's important that you pause your video and write this down. So here, this is the opposite sign. These cancel out. 55 plus 23 is 78. Now we've got 26 times x equals 78. We divide by 26 and x equals 3. Okay, as you see, we will check our work. So I'll check this one here as well. So I'm going to rewrite the original. So now anywhere there's an x, we plug in what we believe our answer is here of 3. So 17 times 3 minus 23 plus 9 times 3 equals 55. Now I don't want the check to be a hard thing, so I'm going to come to my calculator. I want this to be an easy thing. We're looking for 55. So I'm going to type it all in. Now you can handwrite it all out, but again, I don't want it to be hard or long. So 17 times 3 minus 23 plus 9 times 3. Your calculator knows order of operations. So it's going to do order of operations. We've got 55. And that's what we wanted. So I know that this checks. Okay. Okay, so I don't need you to regroup. You regroup, you do that regrouping step if it helps you. So what I'm talking about, let me come up, is right here. This step, all they did was regroup. If you want to regroup, you can. I am okay with, I'm going to circle here, and I'm going to circle my other W over there, and I can see that I need to do 4 minus 13. So again, if that confuses you with your negative, use your calculator. We should get negative 9W, bring down the plus 8 because it's alone, equals 62. Now it looks like a two-step. Okay, so at this point, I'm going to follow the rules for a two-step. So the W stays. I see the positive, so I do a negative. I do the inverse operation. 62 minus 8. I've got 54. I bring down the negative 9W. My last step here is to divide. Positive divided by a negative is a negative. 54 divided by 9 is 6. Rewrite. Replace every W with a -6. So now as you punch this in, we just have to be extra careful. At any point, if you think I'm going too fast, you pause it and write down what I'm writing. Okay, so you have the ability to pause your video whenever you need. 4 times -6 plus 8 minus 13 times -6, and I want to see 62 in my calculator. Perfect. So I know that I got this right. Decimals don't make this any more difficult. We've got our calculator, so use it if the decimals throw you off. Again, we're grouping like terms, and when I group, I'm separating them by circling them. If you want to rewrite them, you can. But I'm going to do 4.6 plus 5.4. I find 10b. I bring down minus 7.5 equals 3. Now it's a two-step. Box in my box in my 10b. Opposite sign here. So I'm adding 7.5. Bring down the 10b. 3 plus 7.5 is 10.5. Divide each side by 10. Cancels here. 1.05. Checking it, I'm going to rewrite. Anywhere I see a B, I'm going to give myself a little more room. I'm going to put in 1.05. Now careful that you're not getting decimals confused with multiplication signs. Go into the calculator. 4.6 times 1.05 minus 7.5 plus 5.4 times 1.05, and I want to see it equal to 3. Awesome. So if you don't, go back and look through what you typed in. Now if you arrow up, it's going to take you back to here, so you can scroll through and reread that and make sure you didn't type anything wrong in there. And if you did, then you can change it right in there. Like if this, maybe you know, right here had a subtraction sign rather than an addition sign, you can change it without typing the whole thing over. Okay, or maybe you missed a decimal. You can insert those in without retyping it over. So if I look, I've got the delete key here. So if you happen to put in 105, I can do this insert. And I always get confused on which one to do. Let's try here. So if I do second key insert and put my decimal, there we go, it went in front of the number. So you want to go to the number behind where you want your missing piece to go. So again, maybe here you missed a time sign. So it looks like this. You want to go behind where you want the time sign to go, second insert time sign, and it popped in front. Okay. 3 equals 3. We got that right. All right. Combine like terms. So here they are our constants. Make sure you pull in that sign. So our variable is alone, does not have anything to add or subtract to it. We're doing 14.5 minus 10.5. Positive 4. We've got our two-step. We worry about that fraction at the end. Positive, so we subtract 4. Bring down my 5/7 y equal to, we do our subtraction. 19 minus 4 is 15. Now we have to get rid of the fraction. So just like we practiced a couple lessons ago, we multiply by the reciprocal. So this gets rid of that, leaving us just with our y. We multiply by that reciprocal over here. We have a calculator, we can punch it all in, but I'm going to do this, I'm going to review with your simplifying. So 5 and 15 have that common factor of 5. 5 goes into itself once. 5 goes into 15 3 times. So 3 times 7 is 21, and I have no denominators left, or I have a 1 right times 1. So y is equal to 21. So I'm going to check my work. 14.5 plus 5/7 times 21 minus 10.5 equals 19. Review that fraction button here. So 14.5 plus, we want to put in 5 ABC 7 times 21 minus 10.5, and we should get 19 equals 19. Perfect. All right. Try the next problem on your own. If you need to use scrap paper, use scrap paper. There's not a whole lot of room on this sheet. Okay, we've got a couple of word problems. Directions: write an equation for each question and solve. Jessica spent half her allowance going to the movies. She then washed the family car and earned $8. Her grandma gave her $25 for her birthday. What is her weekly allowance if she ended the week with $38? Oh, I got an extra dollar. I guess I don't need the word dollars if we have a dollar sign. Apologize for that. Okay, so now we read it again and we underline important information. She spent half, so that's important. of her allowance going to the movies. I don't care where she spent it. She then washed the family car and earned $8. So this is important here. She's got 8 coming in, 8 in her pocket. Grandma gave her 25. So again, that's important. And then the question is always important. What is her weekly allowance? So the allowance is the unknown. If we want to make it X, X is the allowance. What is her allowance? And then if she ended the week with $38, so that's important too. So 38 is the outcome, kind of the answer to the equation. Okay, so Jessica spent half her allowance going to the movies. She then washed the family car and earned $8. Her grandma gave her 25 for her birthday. What is her weekly allowance if she ended with $38? So now let's start piecing this together. Half. Well, half is our fraction, and it's half of her allowance. This is connected right here. An allowance, right, is, well, maybe I should point it over there. Allowance is the X. So we're going to show half of her allowance. Earned, so she's getting $8. Grandma gave her 25, so she's also gaining. And then in the end of the week, she's got $38 here. So there's our equation. We want to combine like terms. $8 plus 25. Now we have that 2-step. Opposite here, so I'm subtracting 33. $38 minus 33 is 5. I bring down the 1/2. Inverse operation. So the fraction, I flip it to 2 over 1 to get rid of it. Here I do the same thing. I multiply by 2 over 1 or just 2. Right? We don't need to show that over 1. Hopefully we know that 2 over 1 is just 2. So X is equal to 10. X is allowance. Right? This is money. $10. I'm not going to check it here, however you can. You've just got to be really confident that this part is correct. If you mixed up your equation, then you would most likely mix up the answer, and the check wouldn't help you because it was the original equation that was wrong. This Halloween, Tom scared twice as many people as Sam, and Roz scared 16 more people than Sam did. In all, they scared 200 people. How many people did Sam scare? Ooh, that's a lot. So, let's underline some important stuff. Tom scared twice as many as Sam. So we do have to keep track of Tom and Sam and Roz. Roz scared 16 more than Sam. In all, they scared 200 people. And then our question, how many people did Sam scare? Well, I like to kind of set these up with separating Tom, Roz, Sam. So they tell us Tom scared twice as many as Sam, and they tell us Roz scared 16 more than Sam. They keep talking about Sam. Well, the question is about Sam. How many did Sam scare? So Sam is the unknown. Sam's your X, or you might want to use an S or any other variable. But now we can write Tom and Roz in terms of Sam. So Tom scared twice as many as Sam. So Tom is twice or 2 times X. Roz scared 16 more than Sam. So 16 plus Sam. In all, right, is all of them added up. So total, 200 people. So 2x plus 16x. So all of Tom plus all of Roz, don't forget about Sam, they equal 200. Combine like terms, so that's all your x's. We've got 2, remember invisible ones, 3, 4, plus 16 equals 200. Now there's that 2-step. Subtract 16 from both sides. I've got 184. Divide each side by 4. X is equal to 46 people. We're looking for Sam. Sam is X. Sam is 46 people. Okay, one more and then answer the last question attached to the video. Kara is making cupcakes for her class to celebrate her birthday. Each box of cupcakes, cupcake mix, makes 1 dozen cupcakes. If she needs a cupcake for each of her 24 classmates, her teacher, and one for herself, how many boxes of cupcake mix does she need to buy? So it's important that we take note that there's 1 dozen in a box. Each box has 1 dozen. She needs one for each of her classmates, so 24 of them, her teacher, and one for herself. How many boxes does she need to buy? So our X is number of boxes. So let's start here. She's got 24 classmates, 1 for herself, and 1 for her teacher. That's gotta equal, right, how many boxes she needs. So in each box, though, we have to take into consideration this 1 dozen. So that's equal to 12 per box. Well, we combine like terms, 24, 25, 26. At this point, we have a 1-step. So we're dividing each by 12. When you do this, we're not getting a whole number. So think about real life when we're planning for these things. So we've got 26 divided by 12 is about 2.16 repeating. So does this mean she needs 2 boxes? Well, let's think about it. If she buys 2, she needs more than 2. So even though this would round, if we think about our traditional rounding, 5 and above, give it a shove, right? If it's under, we leave it. But however, she's not going to have enough if she only buys the 2. So she would need 3 boxes. So even though she only needs a little bit out of that 3rd box, she still needs 3 boxes. So we've got to be careful here. We'll run into these problems from time to time where no matter where it is here, it's not about the rounding, it's about the problem, what's happening in the word problem, and how many does she need. She's going to have to go out and buy that 3rd box, even though the rest, they'll be left over. She keep them at home, or she can, right, bring them to other teachers or other friends. All right, guys, thanks for joining me. We'll see you later.